Welcome back. Good afternoon. Today we are going to talk about that how to integrate the very complicated integrals. Okay, let's look at this integral. I equals 0 to 2 r square root phi minus square root 4 minus r square dr. Very complicated. For sure, we have to use the use substitution or change of variables. Use substitution, change of variables, that's the same thing. Okay, let's look at that what kind of a substitution we can use. I'm going to use let u equals 5 minus 4 minus r squared square root. So this is substitution. I'm going to take the whole thing to thinking that the rest can be taken care of, or you can change the variables. Change of variables, or use substitution, or you can say using differentials. Okay, then what we're going to do, we're going to take the differentials on both sides. I'm going to take the derivative. This becomes 0, this becomes half 4 minus r squared to the power of minus half times the chain rule. If you take the derivative on this one, it's going to be 0 minus 2r. Then du equals minus half 4 minus r squared minus half times negative 2r. 2 get cancelled off, minus minus plus, then du becomes, at the same time I'm going to make this one positive and then change the sign, 4 minus r squared and r, here we have dr as well, and dr. This is dr. See, it seems like at the end of the day you have to take care of, to get rid of r in this expression. Seems like still there are some r terms involved with that one. So I'm going to go to this u back again and try to get r, this whole thing, in terms of u. So I'm going to say from u equals 5 minus 4 minus r squared, I can easily bring this whole thing to this side and bring the u to this side. In that way, 4 minus r squared square root is nothing but 5 minus u. See? Therefore, that quantity I'm going to plug in into this one. Therefore, these 3 dots for therefore, du equals 1 over 4 minus r squared r dr. See? R dr can be replaced with pretty much this 5 minus u r dr. That's du. Now we're going to get the operator. dr is the original operator. Instead of taking just simply r, I'm going to get r dr. R dr is nothing but by taking this whole thing to this side. See? Therefore, r dr is 5 minus u times du. See? Like that. Then we're going to go to the original equation and then change pretty much everything. Before that one, you have to make sure you change the limits. That means when r equals 0, let's see, from with the aid of this one, u is nothing but square root 4 minus r squared. If you're going to plug in here 4 minus 0, 5 minus square root 4, 5 minus 2, which is 3. See? Then you're going to change even the other bound. This is the lower bound, this is the upper bound. R equals 2. U equals 5 minus 4 minus r squared. U equals 5 minus r will be replaced by 2 to the 2. 5 minus 4 minus 4, see, 5 minus 0, which is 5. So these are the new bounds, 3 and 5. Now let's go to the original equation, original integral. The original integral is I square root 0 to 2 r square root 5 minus square root 4 minus r squared dr. Now we can easily change our limits. 0 becomes 3, 2 becomes 5. This whole thing r dr is 5 minus u. See, that we can put that one later. And under the square root, this whole thing is, can you remember, that's our u substitution, that's u. U, those whole thing, this is u. That whole thing is nothing but 5 minus u du. So therefore here I have 5 minus u du. This is 3. Now I'm going to distribute. This time there, that time there. So 3 to 5, 5 u to the half minus u half times u is 3 half du. See, look at what happened. We got very reduced integral at the end of the day. So I'm going to go further down and now integrate with respect to this integral with respect to u. Therefore, I equals 5 u, 1 half become 3 half over 3 half plus 3 half divided by 2 minus 3 half become 5 half divided by 5 half, and it's going to go from 3 to 5. Then I'm going to little bit do the math here. I'm going to bring 2 to the top, then 2 times 5 is 10. 10 over 3 u, 3 half minus 2 bring to the, this one flip, 2 over 5 u, 5 halves. Your limit should be 3 to 5. Then I'm going to plug in the upper bound. 10, 3, 5 to the 3 half minus 2 fifths, 5 to the 5 halves, this first set for the upper bound, minus, I'm going to write for the lower bound. I'm going to plug in 3 here, 10 over 3, 3 to the power of 3 half minus 2 fifths, 3 to the power of 5 halves. Close it. Now what I'm going to do, I'm going to little bit do more math on this one. Then I'm going to write here 10 over 3. I can split this guy 5 to the 1, 5 to the half minus 2 over 5 times this 5 to the 5 halves. I'm going to divide into 2. 5 to the second times 5 to the half. You see? To get a nice final answer. Do the same thing here. 10 over 3 times 3 times 3 to the 1 times 3 to the 1 half minus 2 to the 5th 3 to the second times 3 to the 1 half. I'm going to split that one to get a nice answer at the end of the day. Now let's simplify. So 5 times 10, 50. 50 over 3 times 5 half. I'm going to write, see, 5 to the power of half power, see, square root 5 minus this 1, 5, 5 and get cancelled off. Then 10 over 10, sorry, 10 and square root 5 minus here this 3 and this 3 get cancelled off. 10 square root 3 minus 3 times 2 9, 9 times 2 18 over 5 square root 3. You see? Now let's simplify this one by getting the least common denominator. On this set, you have 3 being the common denominator. Here, then 50 times square root 5 minus 3 times 10 is 30 square root 5. That first set. Minus the common denominator is 5. 5 times 10 is 50. 50 square root 3 minus 18 square root of 3. Then let's simplify more further down. Then 50 minus 30 is 20. 20 over 3 square root 5 minus 50 minus 18, 32 over 5 square root 3. See? Eventually, we're going to have an expression like this. Thank you very much. You have a wonderful day. Take care. Thank you.